1, 0. Hey ho, welcome everybody. What a great introduction. Hey ho, welcome. Welcome to another video. Robert Wolfert here, and today it's not about a randomly chosen tool, but today it's about a dedicated tool. I just wanted to make a short video, a short lesson about the tool grep alone. Yeah, so let's have a look at the grep tool. Grep is the tool that let you, or grep is that tool that let you search within data, that let you search within data, that let you search within data streams. And searching with grep can range from really easy till over to really complex. So let's have a look at this, and let's start with the really easy one. Well, here we are on the demo system, and let's talk about grep. Grep is the tool. If you start grep, let's start easy. If you call grep, you call at minimum, or you give to grep at minimum one single parameter, and this one single parameter is the pattern you are searching for. Yeah, so let's say I want to search for hello, for the phrase hello, simply the phrase hello. And what now happens is that grep reads its data from its input data stream, from its standard input. And the standard input of grep is bound to my terminal. Yeah, to my terminal, and therefore everything I type in with my keyboard will be the input for the grep command. Yeah, so grep reads in the line, grep reads in the next line, and so on. And grep now works in the way that if grep sees the pattern you are searching for somewhere within a line, then grep simply prints out this line. And typically grep marks this pattern with a different color. Here it is colored in red. Yeah, but the main purpose of grep is to just print out the line containing the pattern. Yeah, let's terminate grep here. It doesn't make really much sense to call grep this way, to type all the data in by ourselves. Instead, you would typically take a data stream that is coming from a different command, or you would take the content of a file. Yeah, let's start with the data stream that's coming from a command. Let's say I have a command echo hello world, and now let's say I want to search within this data stream. This is a data stream that comes from a command, and let's say I want to search within this data stream for the pattern, no, not echo, for the pattern hello. And you see nothing happens because grep doesn't find the pattern hello, and therefore grep doesn't print out anything. Yeah, what you see is here that grep sees hello, but hello here is written with an uppercase H, and grep by default searches case sensitive. If you want to use grep for searching case insensitive, because you don't know the case of the words you're looking for, just add the command line switch -I. Yeah, I want to give you some more command line switches in a minute. Yeah, but for now, let's see how grep works. Now grep searches case insensitive, searches or finds this hello because the case insensitivity, and prints out the line hello world. Yeah, you see how grep is working. Let's take another command. Let's take psax, for instance, yeah, to give us a process list. All running processes on a system will be printed out via ps, and let's say I want to search for a process called squid. Yeah, is there somewhere a process called squid or with squid in its name running? And you see we have 1, 2, 3, 4 lines here. Every line contains the phrase squid. Yeah, this line, this, and all the pattern matches here are colored. Yeah. Don't get fooled. No matter if you are searching within your process list, no matter what you are searching for, grep will find always at least one single process, grep itself. Yeah. So if I search for something, for instance, then grep will find only this one line, but this is only the grep itself. Yeah, grep is here run via an alias, and therefore grep -- color equals auto something. Yeah, this is the grep process I have started. Okay, this is one way to use grep, just to have a data stream coming from a command and then filter this data stream with grep and search there for a pattern or for a phrase here. Let's take a different route and let's search within a file. Let's search within a file. Let's say I have a file here called names, now called list.txt. Yeah, I have a file called list.txt, and let's say I want to search within this file. I want to search within this file for txt, for instance. This is a second way for calling grep. Yeah, not piping a content or a data stream to grep, but to call grep with the search pattern and then the file you are searching in. And now grep prints out every line of the file which matches the pattern. Yeah? Let's take a different file here. Let's take the file etc passwd, where all the users are defined on the system, and let's see where the user Robert is the user I'm currently logged in as, where the user Robert is defined here. Yeah, and you see one single line, and you can also see that I can give multiple files to grep. Yeah, it is possible to give multiple files to grep. So to have a look into etc passwd, to have a look into etc group, for instance, and let's see what's in these files. And what you see here is now the output of grep is a little bit different. Now grep prints out at first on the line the name of the file, then a colon, and then the line matching the pattern. Yeah, so in etc passwd, again, one single line. In etc group, we have 3 lines, yeah, where Robert is on the line. Now let's have a look at some interesting options here. Yeah, we already had the option -I for ignore case. So if I want to search for Robert written uppercase, yeah, then grep won't find anything, but grep -I will find these lines containing Robert. A different command line option would be -n. -n stands for numbering. That stands for numbering. And now grep prints out the numbers of the lines. So that now I know that this line, Robert X1002 and so on, is the line number 33 of the line etc passwd. Yeah, and this line sudo is the line 21, this line with Redis is the line 57, and so on. So -n gives you the number of the line just before the output. Yeah, and again, if you have multiple file names as the files where you want to search in, then grep prints out the name of the file where the line was found. If you have only one single file where grep searches in, then you only get the line numbers here. Yeah. Okay, so we had -I, we had -n, and we can use -c if we want. -c stands for count, and -c counts the lines that matches the pattern, that matches the search phrase. Yeah? So you see in etc passwd there is one single line, in etc group there are 3 lines matching the phrase, matching the pattern. Yeah? Okay, so let's summarize this. Grep -i stands for ignore case, -n numbering the line in the output, -c stands for only counting. Yeah? And we are just here on the virtual whiteboard. Let's add the -v command line switch here. The -v command line switch stands for we want to negate the output. We want to negate the output or negate the search. Yeah. If I call search grep in this way, I have a pattern and then the file. Yeah. Or I have a command, pipe the output of the command to grep, and then I have the pattern. Then grep will typically or will by default print out the lines matching the pattern. If you use -v command line, the -v command line switch, then grep prints out all the lines without a match. Yeah. So if you have, for instance, a list of processes running, PS AX, for instance, or PS AUX. Let's say you want to have a PS UX, and it means that you will get all running processes plus you get all the users under which context these processes are running. And now let's say I want to see all the processes not running by root. Not running by root. How can I do this? Well, by simply calling grep -v root. Show me all the lines of the output of PSAUX where root is not within the line. It's not exactly, or these are not exactly the lines where root is the owner of the process. I show you a better way in a minute. Yeah, but this will filter away all the lines containing the phrase root here. Yeah, a different example, for instance, let's again go with etc passwd, all the users on the system, and you'll see we have multiple users. This is the 7th field is the login shell for the user, and the login shell is sometimes been bash, sometimes been false, sometimes been user has been no login, for instance. Now let's say I want to see all the users having been bash as a shell in etc passwd. And what you see is only these 4 lines. Now let's say I want to see all the users not having been bash as login shell. Simply call grep with -v. Yeah. Now we filter away all the lines containing bin bash, and you see only the users with bin false, bin no login, or without any shell are presented here. Okay, so this is another great option of grep -v, for negating the search. If you are searching multiple files, you can search multiple files. We have done it here. We can use simply grep. Let's say if Robert, or let's see if Robert is within etc passwd, etc shadow, etc group, etc whatever. Let's say I want to search within every file within the etc directory. Yeah, then I could simply use this pattern for all the matching file names, or for matching all file names within the etc directory. Yeah. Keep in mind, or perhaps you know, that the shell substitutes this pattern with a list of all matching file names. Yeah. So if let's call this command line simply via echo. Yeah. Let's simply print out this command line, and you will see that the command line looks like this. Grep Robert, this is what I have written here, and then a list of all the files within the etc directory, all the names matching this pattern. And these are all the names within the etc directory. So in this way, grep can really search within a whole directory, but now I would get a real huge number of permission denied errors because I'm here logged in as a normal user and I don't have read permissions for any file, for every file here. Yeah. So I need to call this via sudo grep robert /etc asterisk and sudo to get rid all these permission denied errors. But you see here you have some more error messages left. Yeah, we see some real output lines. This is an output line, yeah, or this is an output line. But these are all error messages. Error messages because grep don't want to search through directories. Yeah, grep throws an error if we call grep within directory. For instance, let's say I call grep directly this way. Yeah, grep robert /etc. Yeah, grep is a directory, etc is a directory. Yeah, the same for this search, or this search pattern for all the files within the etc directory, all these error messages. What can we do about this? Two things. First, we can say we are not interested in directories. We simply aren't interested in directories, so let's skip them. And you can do this via a command line switch -d for directory. And what shall we do with a directory? Skip. Skip a directory. Yeah. And now we see really only the files containing the pattern and then the line printed out. Yeah. Okay. And typically you don't want to see the whole line here. Instead, it would be much better to see only the files. To see only the files where the where a pattern is in. Yeah. So let's do this via the -l command line switch. The order of the command line switches doesn't matter. Yeah, so if something starts with -l or with a dash, this is a command line option for grep. Yeah, and now I only see the lines containing the search pattern Robert. Perhaps a little bit more convenient to read in this way. Yeah, grep -l -d skip Robert etc asterisk. Yeah, and now we see only the files containing lines with the search pattern. Yeah, okay, so we have -l only print out file names with matching lines. We have the -d skip command line switch to skip directories because we are perhaps not interested in these directories. But if we are interested in these directories, if you are interested in the content of these directories, then let's just search recursively through the content of these directories. And you can do this via the -r command line switch. Yeah, -r search recursively through all the directories. Yeah, and this is a different option, yeah, not to skip the directories, but to search recursively through all the files, all the directories within these directories. And you see nowhere else is a pattern match for Robert. And you can prove that -r really searches recursively through a directory by just calling grep via or with this /etc as one parameter to search in. Yeah. And you see grep now does the search instead of throwing an arrow. Yeah. If I would omit this -r command line switch, then grep would throw an arrow. Yeah, /etc is a directory, so -r stands for searching recursively through a directory or through directories. Yeah. Okay, so this is the really simple use of grep. Yeah, just use grep to search within a file, or use grep to search within the output of a command line. And these are some interesting options here. Yeah, we have seen them in action. And now let's talk a little bit more about this pattern here. We are searching here for a pattern, and this pattern could be a regular expression or is taken by grep as a regular expression. Yeah, so let's talk about regular expressions. Yeah. What do we need to know about regular expressions? What is a regular expression? A regular expression is, simply spoken, a type of pattern you can formulate to define nearly everything you want to find within a text, you want to match within a text-based data. Yeah, so a regular expression is simply a type of pattern you can use. And if you have a pattern, you can write a pattern, then you have some placeholders there. And for instance, one placeholder in the pattern in a regular expression is this character. Yeah, this caret character. I think it's called this way, the caret character. This can be used to mark, or is used to mark, the start of the line. The start of the line. And we have the $sign, and the $sign. This is used to mark the end of the line. Yeah. So, let's have a look at these two pattern parts in action. Let's say I want to again I don't have any different data here. I just use etc passwd for data, for searching, and I just want to see the user. Let's say I want to see the user bin. There is one single line for a user called bin. Here, this single line, this is the user bin. Yeah? So if I search for the user Robert, I simply do this way, grep Robert etc passwd as seen. If I'm searching for the user bin, I could try it this way, yeah, but it isn't the output I would expect for the user. And instead, I get here really every line of etc passwd, just because somewhere within every line in etc passwd is the phrase bin. Yeah, bin is contained within every line. So we want to search for the one single line where bin is at the start of the line. We have a start of the line, then we have bin, and then we have a colon. And this is exactly this single line where the user bin is defined in. Yeah, such or just this caret sign, I think, for the line start marker, or as a marker for the start of the line. A different use case could be or would be the output of ls-l. Yeah, and ls-l prints gives you a detailed output of the current directory, for instance, or of a different directory. And you see here in this detailed output that you have a first flag for every line showing the type of the file. And you have here directories starting with a D. You have regular files starting with a dash here. And let's say I want to see only the directories. I want to see only the directories. So I'm searching for all the lines starting with a dash. With D, sorry. Yep. So these are the two lines showing directories here. Yeah. Now we don't have the blue color in the output because the ls command sees that the output doesn't go to a terminal and therefore it doesn't color the output. Yeah, but grep gets all the text-based data here, line-wise searches this text-based data and prints everything out and colors the pattern it has found. Yeah. And now let's say I want to see every line here in the output of ls-l, for instance, ending with an F. Yeah. And we can do it simply this way, grep. Yeah. And now we are searching for an F, but not for an F somewhere within the line, but for an F followed by the end of the line. Yeah, so the $sign is the end marker, or a marker for the end of the line, and now you see only this single line. Yeah. Okay, so you can use this, for instance, for searching for empty files. Are you interested if there are empty files within some file? Let's say we have the file etc profile, and this is a simple script that is started every time a user logs into a shell. And let's say I want to grep I want to search for only empty lines. Oh, empty lines, really empty lines, are lines where there is the start of the line directly followed by the end of the line. Yeah? And you see here we have 1, 2, 3, I think, empty lines. Let's count them, grep-c. Oh, 2 empty lines. Okay, yeah, there are 2 empty lines we have here. Okay, these are 2 placeholders or 2 special characters for regular expressions. There are more. For instance, there is a dot. There is a dot that stands for one single character. One single character, doesn't matter which character, yeah, the dot stands for any single character. So let's say I search within the etc passwd for start of the line, 2 characters, colon, yeah. What I'm searching for every line where we have 2 single characters and then a colon. So I will get the one line containing a user with only 2 characters. Yeah, with a username that consists of only 2 characters. Let's try this with 3 characters. Okay, we have usernames with 3 characters. Let's try this out with 4 characters, and you'll see not perfectly because we have this line too. Yeah, just because one single character this is one single character, the first, the second, this is the third single character, this is the 4th single character, and then we have a colon. So this pattern matches this line too. But we only want to see usernames consisting of 4 characters. How can we accomplish this? Yeah, well, simply by not saying a single character of choice, but a character from a range or from a list of allowed characters. Yeah, so a dot stands for one single character, and if you have these square brackets and something within these square brackets, single characters, a list of characters, then this stands for one single character from the list, from the given list. Yeah. So this example here would be one single character, an A, and B, or and C. Yeah, one of these 3 characters, but only one. So let's do it here. We are searching for usernames containing only 4 characters, and so we have 4 characters. The first character is A, B, C, D, E, F, G. Now we don't have to write everything here. We can just use ranges. Yeah, A to Z, and then again A to Z, and then again A to Z, and then again A to Z, yeah, and then the colon. As an example, you see we have really only the 4 character names here. But this isn't perfect. This isn't perfect at all, just because there could be a username with uppercase letters. Yeah, there could be a username with uppercase letters. So I would have, I don't do it, this, append everywhere A to Z uppercase. The next would be numbers within usernames. Numbers are allowed within usernames, but not within the first field, but in all the following fields. So I need to append 0 to 9, for instance. Then I need to append some special characters that are allowed. I need to append a dot. I need to append a dash, a minus sign. I need to append underline. I'm not sure. I'm not really sure if underline is a valid character of a username within a username. But what I know is that one character is definitively not allowed within a username, and this is the colon, because the colon here is the delimiter for the fields within the file. And we can use this knowledge, yeah, to just write we have something not, one character not in a given list or not from a given list. One single character not from given list. Yeah. And in this way it would look like this. We have a character, one single character. This is not a colon. And then we have a single character. This is not a colon. And again, not a colon. And again, not a colon. Yeah. Don't get confused here. Yeah, this character is within these square brackets. It is a negation. If it is the first character within the square brackets, then it is a negation. If it is without these square brackets, then it is the start of the line marker. Yeah. So now I have really only the usernames with or consisting of 3 letters, 3 numbers, 3 characters. Yeah. And there are some more special characters you could use here. For instance, let's take the last one here. For instance, an asterisk. Oh, What stands the asterisk for? The asterisk is a repeat operator. The asterisk stands for the thing defined directly before the asterisk, repeated any time. Yeah, repeated multiple times, repeated none time. Yeah, not even one single time. So asterisk or dot asterisk is the same in the shell as the real asterisk, as you know it. The asterisk in the shell for the file name search patterns, yeah, stands for any number of any characters, and this is the same pattern here within a regular expression. Within a regular expression we have a dot. This is one single character of choice, and this repeated any number of times. Yeah, zero number of times until quadrillions number of times. Yeah, so these are the placeholders you can use in regular expressions, and it gets, or it can get, a little bit more powerful but also complex. Yeah, just because there are not only these normal regular expressions. By the way, there are some more patterns here, some more placeholders, one or two more placeholders here. See the manual page for the POSIX regular expressions. man7 regx is a manual page you will find on every system where grep or something like that is installed, and grep is installed everywhere. Yeah, so have a look in the manual page of the regular expressions. There is another type, a second type of regular expressions, and these are the extended regular expressions. Extended regular expressions. And these extended regular expressions can do much more. They can become really complex but really powerful. Yeah. For instance, you have here a repeat operator for repeating something any number of times. And within extended regular expressions, you could write something like this. You have somewhat an A, for instance, and you are searching this A exactly 4 times or exactly 2 times. This is a repeat operator within extended regular expressions, and there you could say you have something, whatever, repeated a number of times, or repeated a minimum number of times, but a maximum number of times, or until a maximum number of times. So this stands for the A 2 times, 3 times, or 4 times, for instance. Yeah. So these are some things within extended regular expressions. You could do things like this. You're searching for root or Ubuntu. Yeah. You can here define alternatives. Yeah. Just by enclosing them within brackets and separating them by a pipe sign. Yeah. So these are regular expressions, and there are many more available. Really many more. So, but you have to know the difference between the default or the POSIX regular expressions and the extended regular expressions. Just because grep can handle both, but in a different way. And so can all the other tools on the Linux command line that they take regular expressions somewhere. They can handle both default or POSIX regular expressions and extended regular expressions, but in a different way, really in a different way. And let's say I want to search here. I want to search within. Let's have a look here at some examples for the whiteboard. And let's search within etc passvd for the user named root, or Ubuntu. This is really this pattern here as an alternative pattern. Yeah, we are searching for first start of the line, then root or Ubuntu, and then colon. And you see nothing happens. Robert, did you lie to us? It's not really a regular expression? Yes, it is a regular expression. I didn't. I told you the truth, but grep by default doesn't use extended regular expressions. By default, grep doesn't handle extended regular expressions. You have to tell grep to do so. Yeah, and you can do this via the command line switch -E for the extended regular expressions, or you can do so by calling egrep instead of grep. Yeah, egrep. And now we see we have these two lines and this pattern works. But we can use extended regular expressions without using -E or without using egrep, just by saying to grep, we are searching for the start of the line, then the opening bracket, but oh no, we are not searching for the opening bracket. This is a special character. And you may know how you mark special characters within a shell. You simply write a backslash before the special character, and here you can quote or mark backwards. You can say to the grep, this is a special character. Yeah, have a look, grep. This is not a curly bracket. This is a thing from a extended regular expression. Yeah. And the same goes for this, and the same goes for this. And now it works. Yeah, and this is what sometimes the usage of these regular expressions make a little bit difficult. Yeah, you are searching the internet for some regular expression. Yeah, and then you find something. Someone says, here is a regular expression that does exactly this, what you want to do, and you take, by using copy and paste, this regular expression and handle it to grep, and you see nothing happens. Yeah, because either it is an extended regular expression and therefore it doesn't work by default. Yeah, or it is written as extended regular expression for grep in this way, but you are using egrep or you are using grep-e. Yeah, because now grep uses extended regular expression, and this means no, this isn't a pattern for an extended regular expression. This is only a bracket. Yeah. Okay, so you need to know which types of patterns belong to default POSIX regular expression and which belong to extended regular expressions. And then you need to know if the command you use uses by default extended regular expressions or not extended regular expressions. Yeah, and then you have to write perhaps the regular expressions in a different way. Yeah, that goes for all the tools that takes regular expressions at the command line. Yeah, you can use find, you can use or search within the VI, for instance. You can use awk, yeah, with regular expressions. Okay, this is really, really important to keep in mind, is that there is a difference between interpreting regular expressions and extended regular expressions. Okay, the last thing for today is one command line option. Let's append this command line option here recursively. Okay, let's append this command line option here. Let's take the command line option dash lowercase o. Dash lowercase o stands for please grep, not print out, do not print out the whole line matching the pattern. Please print out only the part matching the pattern. And this is a really, really powerful command line option here. I'll show you an example or some examples in a minute. Dash O, print out only the matching part of the line. Yeah, okay. Print out only the matching part of the line. So let's have a look. Let's search for, as an example, let's search for root or Ubuntu in etc passwd. Yeah, we have done this before, but we don't want to see the lines. We only want to see the matching parts of the lines, and we can do this with dash O. Yeah. Now we see only the usernames. Yeah. Let's say I want to see only the home directories. I want to see only the home directories. Yeah. Let's try this out. Somewhere within the etc passwd there is a field. Yeah. Starting with a colon, ending with a colon, and this field starts with /home. I want to see only the home directories within home. Yeah, and I could write it this way. Yeah, we have home we have /home then any number of any character, but not the colon, anytime repeated. Yeah, within etc passwd, and you see these are the colored parts here are the matching parts. And now you can say to grep, please print out only these matching parts. And here we are. Yeah. And this is really, really powerful. Imagine scenarios where you want to extract IP addresses, for instance, from a file. Yeah. No matter where within a line the IP addresses, in which context the IP addresses are written into, yeah, you can search for IP addresses. You can search for, yeah, for instance, 0 to 9, not really for an IP address, but you get a point, I think 0 to 9 and 0 to 9, and then comes a point, a dot, comes a dot, yeah, and then the next characters and so on. Yeah. Could we do this in a better way? We have a regular expression here. We could say, let's do this with an egrep, an extended regular expression. Let's say we have a number 0 to 9. Let's take the number 0 to 9. Yeah, no thinking about the 8 bits here and so on. And this 1 or 2 or 3 times. Then we have a dot. And then we have again 0 to 9, 1 or 3 times, and a dot. Again the same, and again the same. Yeah, but not a dot at the end. So, and now we could use this for searching, for instance, in a file where IP addresses should be in etc hosts. Yeah. Okay. And you see, really, there are IP addresses within this file. Yeah. So great. And this is a really, really powerful command line option here for the grep command. You can do really many more things with the grep command. Yeah. But I think these are the most important things you will do on your system if you're working at the console. If you're interested more in such tools like the ones I talk about here, like the ones I talk about in other different videos, yeah, these tools are taken from the Shell Toolbox. The Shell Toolbox is a book I have written at first for my clients to give them an overview, a handout for all the tools they can use for their daily work with explanations and with sample calls. And now you can have access to this book too. If you're interested in, the Shell Toolbox is available at shelltoolbox.com. Yeah, if you're interested, go to shelltoolbox.com. If you learned something new, if you liked what you have learned, yeah, please let me know in the comments. Also, if you have some questions regarding this grep tool, regarding regular expressions, regarding something else, yeah, let me know in the comments. Yeah, and see you next time.